Hello everyone, I hope y'all are doing well. This is lesson 12, Recursion. In this lesson, we will be going over recursion in general, why recursion is useful, the base case, tracing recursion, binary search using recursion, and merge sort. Alright, to get this lesson started, you're going to want to go up here to this folder where you have currently saved everything and launch the package. Then you're going to want to create a new class called lesson 12. And I have already created the entire class over here because we will be utilizing several methods within this class when we will be talking about recursion in terms of binary search and merge sort. Since this is quite a bit of code, I have already written out all of the code, and I will give you a chance to copy all of the code later in the video when we get to that part of the lesson. So let's talk about recursion first. So recursion essentially happens when a method calls itself. Let me give you an example. So say we have a method, public static void never end. All right, and this method has no return type and it doesn't take in any parameters as well. So all I'm going to put inside this method is a simple print statement, system.out.println, and this method never ends. And there you go. And remember what I talked about when we're doing recursion. Recursion happens when a method calls itself. So we have to call this method. So I'm just going to call this method never end. Let's see what happens when we call the never end method inside our main method. Whoops, there we go. Right, I'm going to call the main method void main string args. See, we get an infinite loop. The reason for that is because, hold on, let me just stop this over here. Because we are printing out the statement, then we call the method again, all right, then we call this method, print it out, then we call the method again, all right, print. See, we just keep calling this method and there is no termination condition. So this loop never ends, so that's what makes it an infinite loop. We consistently call this method over and over again without giving it any condition to terminate or stop. So that's essentially recursion in simple forms. Now you may be asking, why is recursion useful? Recursion is most useful when it is used to solve problems where the structure of the problem repeats. For example, what if you wanted to find out how much space a folder on your computer uses? You could add up the sizes of all the files in that folder, but folders can also contain subfolders. So you will have to repeat the procedure, or method in this case, for each subfolder. Each subfolder can also contain subfolders. Recursion can also be used to create fractals. A simple example is Simpersky's triangle, which you divide a triangle into 4 new triangles, and then you can do the same procedure with each new triangle except the center one. Another common example for recursion is factorials. So let's say we write out another method for calculating factorials. Here, let's get rid of this so that we don't have any errors. And we're just going to have public static int factorial. And the reason why I'm returning an integer is because a factorial is usually returned in an integer if we're going to pass in an integer. So I'll also pass in an integer number. Right? And then within this method, we're going to have a case, all right? If n equals 0, then what we want to do is return 1, all right? Well, then you may be asking, all right, so what exactly does this method accomplish right now? This will only return anything if n is 0. Well, that's where we have an else case. And inside here is where we're going to call the method. So we're going to do return n times factorial n minus 1. So essentially what's going to happen is n is going to decrease through each iteration of this loop that we have created by calling the method over and over again. And we're going to multiply all of these values out until it reaches 1, until n becomes 0. So that's where we return 1. So we're going to have 1 times this method, and it's just going to keep calling itself over and over again. So let's try it out. Say you wanted to get the factorial of 3, all right? So let's print that out. Factorial 3, all right? So essentially, what should it return? Well, 3 times 2 times 1, that's equal to 6, all right? So it should return the value 6. Let's give it a try. 6. See, it worked out properly. Let's try a bigger number. Say we try 5. Then we have 5 times 4 times 3. All right, 6 times 20, that's 120. So we should get a value of 120 now. Let's give it a try. 120. All right, now let's, trace through this code. So we had talked about tracing. So let's see what this method is actually doing. All right, so we have the value 5. We'll do comment and we'll start tracing. So when we pass through 5 over here, 5 is not equal to 0, so we go to the else case. Then what we're going to want to do is return n times factorial n times n minus 1. All right, so n currently is 5. So we have 5 times, and then we have factorial, and n minus 1, which is 5 minus 1, is equal to 4. All right? Then, what do we have? So then we need to calculate what factorial 4 would return. So factorial 4 returns 4 times factorial. And then we're going to have to decrease n by 1 again, so it becomes 3. Okay, so this is what it's going to return. 4 times factorial 3, and this is the first statement. All right. Then we're going to have to see, all right, what does factorial 3 return? So factorial 3 is going to return, so we have n first, so 3 times, and then we have to do factorial minus a value less of what the current n value is, which is 2. All right, now we have to calculate what does factorial 2 return. So factorial 2 returns, let's see, so we have n value, which is going to be 2, and then factorial 1, all right? Then essentially we're going to have to calculate what factorial 1 is going to do. So factorial 1 is not equal to 0, so we go to the else statement, and we're going to get 1 times factorial 0, all right? Now, what would factorial 0 return? So that means that the n value is 0, 0 equals 0, so now factorial 0 is basically equal to 1. It's going to return 1. So that means factorial 1 is going to return 1 times 1, which is 2. So factorial 1 is now 2, so that means this is equal to 2. Now factorial 2 is going to be equal to 2 times 2, which is 4. All right, so we can replace this factorial 2 with 4. And then factorial 3 times 4 is 12. All right, and then we can replace this factorial 3 up here with a 12. And then 4 times 12, that is 48. So factorial 4 is equal to 48. And then we replace it over here. 48 times 5, 120, right? So we essentially get the value 120. See, that's how it works. So you just have to keep going all the way until you get to the last case, and then you just start replacing each of what you know. So what that last case is called is the base case. So every recursive method must have at least one base case which halts the recursion. This is usually an if statement that causes the recursion to stop by just giving an answer without needing a recursive method call, or in other words, you're just not calling the same method back. So you can also think of it as the simplest case where you can give the answer right away. The factorial method has a way to stop the recursion, in other words, not call itself again. It stops when n is equal to 0 since it just returns the value of 1. So this would essentially be known as the base case in the factorial method. So pretty simple. So the never-ending method that we had written did not have a base case. That's why it caused an infinite loop, which was causing errors when we started to print it out. So now that you have a general idea of how recursion works, let's talk about how recursion is used in binary search. So we had done it originally through loops like for loops, while loops, all of that. And it's still going to work on arrays, except this time to loop through all of them, we're going to be using recursion and calling the method over and over again. So here, I'm just going to hover over this, and you can pause the video for a couple of seconds and get down all of this code. So I'll stop here for like 2 seconds. 1, 2. All right. So essentially what you need to know about this method, it looks pretty similar to how the original binary search looked when we were using loops. We calculate the middle. We are seeing if the target is less than the middle. We're also seeing if end is less than start, and target is less than array and middle, and target is greater than array and middle. Looks pretty similar to how it was. So I'm going to essentially go through this, and remember how binary search worked. You'd go through half of the array, and then you'd keep going, getting half and half and half until you get to the desired value that you want. And binary search is good in especially large cases when you want to put in large amount arrays. So that's pretty simple, and let's see if we can find the base case here. So return middle, all right? That's not calling the method, so that can act as our base case. Return -1, that can also act as a base case. So in this method, we actually have 2 base cases because we need to have one for the time that it is not found and one just to end the recursive method whenever we're going through everything. So pretty simple. And then this is where we're calling the method again. So these can't be our base cases because we're just recalling the method over here. So in this case, we have 2 base case methods. You can take the time to go through and trace through this. I'm not going to go through it because we've done it throughout the binary search. And again, if you didn't remember how to do binary search, then you can go out and check the searching/sorting video. All right. So then we're going to be also talking about a new type of sort that we didn't talk about before. We only talked about insertion sort, selection sort, right? So then we have a new one called merge sort. So binary search was for searching for a specific value. So we had selection sort and binary search. And remember, for here, we had selection sort and insertion sort. But with recursion, we can do another type of sorting, which is much more efficient than insertion sort, especially in large, arrays. So merge sort is actually more efficient or faster than selection sort and insertion sort because it divides the problem in half each time like binary search. This is called a divide and conquer algorithm. The merge sort recursively breaks the values to be sorted in half until there is only one value to be sorted, and then it merges the 2 sorted lists into one sorted list. The code shown below uses a second array, the same size as the original array for merging the values in order. Then it copies all the sorted values back into the original array. So this is the code that I mean when it meant below. So here's all the code. I'll hover over this in each second for about 2 seconds so you can pause and get down all the code. So pause here for a second. You can pause the video and copy it again. All right. Let's go down to the next section, and you can also copy down all of this. Here we go. Keep scrolling down at these next second of loops. And there you go. So now that you have paused and copied down all of the code, let's actually go through this. So essentially what merge sort is going to do, this is actually a very complicated algorithm. So what I'm going to recommend for you guys is there is a link pasted to the description of this video, and it will take you over here to Java Visualizer, and you can basically trace through this code. So just hit this forward button every time and it will start tracing through the code, and you can follow along, and it has nice graphics as well. So you can just keep going through it and see what it does. I'm not going to go through it because if you start going forward, there are many loops and this gets very complicated. So, and it will also take a long time, and I don't want to kind of keep you guys here for a while. So I recommend just going to this link, Java Visualizer. Again, the link is pasted in the description below, and you can go and check that out. All right. So I'm just going to give a brief summary of what merge sort does. So here we go. So we have our method over here, and you can see over here, we're utilizing several private methods. So merge sort uses 3 methods in total. One is the main merge sort, and then we use the merge sort helper, and then this merge sort helper uses this. The reason why these methods are private is because we do not want the client code to access these methods, because the client code doesn't really need these methods. All the client code needs is this method. These methods are just helper methods. They're there to just help this main method out. So this would be considered the main method in terms of merge sort, and that's what we would call in the main method. So let's give it a try. And then I'll give a brief trace through it, not the extensive trace, but I'll show you what it does, just so that you have a good idea of how it works. So we have our array, all right? And let's say we put in some random values, 86, 3, 43, and 5. All right, just 4 values. We'll keep this short and sweet. All right, whoops, I need an equal sign. And then I'm just going to print out this array to show you what it looks like before. So let's do arrays.toString R1. So if you guys didn't know, arrays.toString is actually going to print out the array. That's similar to how you would print out an array list if you just throw in R1. This is not part of the arrays class, so it's part of the util package. So that's why I've imported the util package up here so that we can use this method. So this is the method arrays.toString R1, and it'll print out an array. If I had just thrown an R1 over here, we just get a memory address because the array class doesn't have a toString method, but this Java util package has the toString method for the arrays class, so you can just use that. All right, and then I'm going to call merge sort. That's the method down here. Again, that's the main one that we use. And then all I'm going to put in there is our array. Then we'll print out the array. Here, I can just copy this statement. We'll print out the array after it's changed. So essentially what the method's going to do is change the array that we have already put in there. So let's give it a try. Let me print it out for you guys. There you go. So here is the original array, and then we call the merge sort, and we got the sorted array. So let me go through and show you guys how it worked. So essentially what you guys have is on the first pass, we have split 1, right? So it's going to split the array and keep splitting it, and then slowly bring the arrays back together in a sorted fashion. So let me show you what I mean by that. So we have our array, so we're going to split it in half first. So we have 86 and 3, all right? Then the second half of this main array that we had is 43 and 5. So if you look up here, this is our array, so essentially what I did is divided it into 2 sections, here and here. Section 1, section 2. All right, now we have to divide these into half. So let's do that. So we have our second pass, right? And this is going to be known as split 2, right? And let me just go through and do it. So I'll just keep track of it over here. So we have 86. Then we have 3. All right. And then we close the second section. And then we have this section over here. So we're going to have 43. And then 5. All right. There you guys go. So we've essentially broken down the array by half each time. So when we put this array back together, we're actually going to be putting it in a way where it's already sorted. So let me show you what I mean by that. So we split it up and we're going to put it back together and we're going to sort it as we put it back together. So on pass 3, this is going to be known as the merge. So merge 1, all right? And let me just put colons here so that we can separate the arrays from the actual passes. So let's bring it back into our 2 sections. So within this, we have to sort this specific section. So we have 3, right? And 86. So we joined these 2 back together, but now it's sorted. So we put them together in a sorted fashion now. Now we have to do the same thing for the second section. So let's see, 5 and 43. Let's sort that as well. 5, 43. So essentially you're going to be putting these back together 2 at a time. So no matter how long the array is, you're first going to get it into individual segments and then you're going to put it together 2 at a time. Each section 1 at a time. Combine 2 sections 1 at a time. So there you guys go. And then we just have one more pass left, and that's merge 2. So then we have to put these 2 sections together. So we've already sorted these sections, and now all we have to do is put them together in a sorted fashion. So you get 3, 5, 43, 86. So it's actually very efficient. So we break it up and put it back together, but we sort it as we put it back together. So that's essentially how merge sort works. Again, if you would like to trace through this entire code, I have pasted the link for the Java visualizer. The code is exactly like it's seen over here. It has the main method exactly like this, and it has all of the methods starting from here. So you can just go through that and see how it works when you trace through it. And again, if you forget how to trace through it, then you can rewind the video and you can look at how we trace through the factorial method. So it was a relatively short lesson today. I hope you all enjoyed it. Again, if you do not understand anything within this lesson, please do not hesitate to scroll down to the bottom of this page and find information regarding how to schedule a tutoring appointment. And you can also schedule tutoring appointments if you have any questions about computer science in general. I hope you all have a great rest of your day, and thank you for listening.